You might be telling me, sir, but there are no angles here. We were not given any angle here. So how do I know how to answer this question? No, there's no number at all. It is very simple. So what you're meant to do is for this equilateral triangle, you remember that the sum of angle in a triangle is 180 degrees. So if you divide 180 degrees into 3 equal parts, that's 180 divided by 3, it's going to give you 60 degrees. That means for this triangle B, which is an equilateral triangle, each of the angle is 60 degrees. Are you getting what I'm saying? If 180 divided by 3 is 60 degrees, so that means each of these is 60 degrees. So here is 60 degrees, here is 60 degrees, then here is another 60 degree as well. Now, for us to answer this question, we are looking for the size of angle QRS. So to get this side, we need to get the upper portion here, the upper angle here. And then we're going to add the two together to give us this angle. So how do we get this angle? So for this series, we are talking about the circle theorems. All right, a lot of students have issues with the circle theorem. So I'm going to be giving you 1 or 2 theorems in 2 minutes, very simplified, so that when we break it down like that, you can actually get to understand all the theorems over time. Now let's look at the first one. Now, this is the center of this circle, and this is a chord. A chord is a line that joins two parts of the circumference, 2 points on the circumference aside the diameter. So this is a chord. So this first theorem says a line that runs from the center of a circle to this chord, right, divide this chord into 2 equal halves. That is number 1. It will divide this chord into 2 equal halves. So if the length of this chord is 10 meters, that means this part is 5 meters, this part is 5 cm rather, not meters. Are you getting it? So let me repeat that. The rule says a line that runs from the center of a circle to the chord is perpendicular to the chord, and it divides the chord into 2 equal halves. It is perpendicular to this chord. This line running from the center of a circle is perpendicular, means it forms angle 90 degrees with this chord. Number 2, it divides this chord into 2 equal halves. So, and you remember the line that runs from the center of this chord or this circle to any portion of the circumference is called radius. So the meaning of that is this point to this point is a radius. So if this point to this point is radius, is the same thing, this point to this point is also radius. So that same rule now can be interpreted that becomes a triangle. This hypotenuse has the same length as this hypotenuse. So if they ask you to find the radius here, they ask you to find the radius, you were given this 5 centimeters, so the question could ask you to find the radius. It can ask you to find the distance from this end, this center, to the chord. They can ask you to find the length of the chord. But just know this is a triangle in a circle, and that is now, so to answer a question like this, it will now lead you to Pythagoras theorem. So if the length of this portion, let's say the length of this portion is 4, and here is 5. So you just bring out the right angle triangle. So now you have a right angle triangle. You have 4 here, you have 5 here, you have x here. This is the hypotenuse, this is the opposite, this is the adjacent. So you are going to use your hypotenuse squared equals to opposite squared plus adjacent squared. That is Pythagoras theorem. So that's going to be x squared equals to 4 squared plus 5 squared. X squared equals to 16 plus 25. And your x squared, 25 plus 16, it's going to be 41. Yes, 41. And so you find the square of both sides. So your x, the radius, which is now the radius, is going to be square root of 41. That is the answer. So root 41, that is the radius. So let me recap this rule again. A line that runs from the center of a circle to any chord, okay, in this circle is that line is perpendicular to the chord, meaning it forms angle 90 degrees, right? Number 2, it divides this into 2 equal halves. I hope that is clear. allow you to write this rule down before I go to the next. Okay, or you have done a screenshot of this. Okay, now let us go to the next. Here is the second theorem. When you have a circle, all right, and then you have a quadrilateral inside the circle. That means you have a shape that has 4 angles, 1, 2, 3, 4. Now, the two opposite angles are complementary. What's the meaning of that complementary? They sum up to 180 degrees. So when I say they sum up to 180 degrees, so if this part is 100 degrees, here will be 80 degrees, because 100 plus 80 is 180 degrees. These two also, they are opposite, all right, or they are complementary, rather they complement each other. They add up to give 180 degrees. So if here is 120 degrees, here will be 60 degrees. This is the second theory, and it is very simple. So let us try to write down this theorem. It says, for a quadrilateral inside a circle, the complementary angles add up to 180 degrees. That is, so let's try to label. Let's say angle A, B, C, D. So that means angle BAD, that's 120 degrees, plus angle BCD. BCD means the angle is on C, which is 60 degrees. A is equal to 180 degrees. And the same is applicable here. ADC is also equals to ABC, meaning 100 plus 80 equals to 180 degrees. So equals 180 degrees. That means 80 plus BAD, that is 120 plus BCD plus 60 equals 180 degrees. All right, so that is the second theorem. Let us look at theorem 3. Now, the theorem 3 says when you have an angle here and you have another angle here, you see these two angles, they are in the same segment. What do I mean by the same segment? If I draw an imaginary line here, that cuts through here, all right, that line is a chord. Remember, a chord is a line that joins two parts of the circumference aside the diameter. The diameter is usually the line at the center, but this is not at the center, so it's a chord. Now, this portion within the chord, all right, if I shade this part now, if I shade all this part, this portion within the chord, that is what you call a segment. So this theorem says any angles, the angles within the same segment are equal. So if that is the case, if here is 30 degrees, here too is 30 degrees, because they are angles within the same segment. And the same is applicable to this point as well. If I do an imaginary line here, this angle and this angle, they are within the same segment. So they are also equal, right? So the theorem says angles within the same segment are equal. So if I have A, B, C, D, that means angle CAD. So that is CAD, angle CAD is equal to angle CBD. Angle. So the meaning of this thing I'm putting on top of A means the angle is on A. All right, CAD, but the angle that we're talking about is actually on A, is on the middle value. This can also be written as angle. You are seeing the symbol? Angle CAD equals to angle CBD. So this and this are the same. So CAD is equals to angle CBD. That is the third theorem. Let us look at some more theorems. Let us try to apply one of the theorems that we have considered, all right, to answer this question. The question is, in the diagram, line PQ, that is PQ, is equals to line QR, and line PR equals to line RS equals to line SP. When you see this, it means line. So they can either write it like this, line PS, or they can write it as this, PS, and put a line on it. Is that okay? So line PS, okay? Now, that is number one. Number two, they now say calculate the size of angle QRS. The size of angle QRS. So we are looking for here and here joined together. Looking for the two. But before we continue to try to apply theorems, looking at this triangle or looking at this circle and the shape that you have in it, what comes to mind? We can see there is a quadrilateral here. There are 4 angles, right? And the lower part is a triangle. The lower part is a triangle that has this symbol, one mark, okay? While the upper part has 2 here, but 1 here. These marks are not by mistake, right? The meaning of this mark is this line, okay? These sides, 3 sides of this triangle are equal. They are equal. So the meaning of that is this triangle here is an equilateral triangle. What's the meaning of equilateral triangle? It means they have 3 sides are equal and the 3 angles are equal. So the 3 sides in this triangle, so what is what I'm talking about, this triangle A, this triangle B. For triangle B, the 3 sides here, here, and here are equal, and these 3 angles are also equal here, here, and here. So the 3 angles are equal, the 3 sides are equal. While for triangle A, can you see this double line, but a single line here? This is an isosceles triangle. What is an isosceles triangle? Isosceles triangle has 2 sides angle and the 2 base angles are equal. 2 sides equal rather, 2 sides are equal and the 2 base angles are equal. So this angle and this angle are equal. So as you can see, I want you to pause this video and try to answer this question based on the explanation I've given to you. Okay, if you have tried that, you might be telling me, sir, but there are no angles here. We were not given any angle here. So how do I know how to answer this question? No, there's no number at all. It is very simple. So what you're meant to do is for this equilateral triangle, you remember that the sum of angle in a triangle is 180 degrees. So if you divide 180 degrees into 3 equal parts, that's 180 divided by 3, it's going to give you 60 degrees. That means for this triangle B, which is an equilateral triangle, each of the angle is 60 degrees. Are you getting what I'm saying? If 180 divided by 3 is 60 degrees, so that means each of these is 60 degrees. So here is 60 degrees, here is 60 degrees, then here is another 60 degree as well. Now, for us to answer this question, we are looking for the size of angle QRS. So to get this side, we need to get the upper portion here, the upper angle here, and then we're going to add the two together to give us this angle. So how do we get this angle? You remember, so now we are going to apply the theorem. One of the theorems says these two are opposite angles, they are complementary angles, and complementary means they add up to 180 degrees. The same with this and this. So when you have this quadrilateral, right, inside a circle, the rule says these two opposite angles that are facing each other, they are complementary, meaning they add up to 180. So if here is 60 degrees, what will I add to 60 degrees that will give me 180 degrees? It is going to be 120 degrees. So here is 120 degrees, right? So here, 120 degrees. So if that place is 120 degrees and here is 60, that adds up to 180. And for us now, for this triangle A, since we already have one angle, and you remember we said these two sides are equal because it's an isosceles triangle, and the two base angles are equal. So what will be the two base angles? Very simple. So all you need to do is remove 120 from 180. You'll be left with 60, and you're going to now divide that 60 by 2. So for us to get this part, the first thing is 180 minus 120. That's going to be 60 degrees. So that means these two angles will sum up to give you 60 degrees. So I'm going to have to divide this by 2. So 60 divided by 2, 30 degrees. So that means these two base angles, which are equal, they are 30 degrees each. So 30 degree here, 30 degree here. All right, so if you look at this upper triangle now, this is a triangle. The sum of angle in a triangle is 180 degrees. 120 plus 30 is 150 plus 30 is 180. Look at the lower part. It's another triangle. 60 plus 60, 120 plus 60, 180. Then these opposites they are complementary. They add up. 120 plus 60 gives you 180. Now, if you look at this angle and this entire angle as well, they are complementary and they add up to give you 180 degrees. 30 plus 60 is 190 degrees. 30 plus 60 is 90. 90 plus 90 is 180 degrees. So now let's go back to the question. The question says, in the diagram, calculate the size of angle QRS. QRS will be 30 plus 60. Therefore, it's going to be 90 degrees. So the angle QRS is going to be 30 degrees plus 60 degrees. That's going to be 90 degrees. Do we have that in the option? Yes, that is option C. And that is how to tackle the question. Can you see initially there was no number here, but with your understanding of triangles and the theorem, the circle theorems, you'll be able to provide solutions to this question. So you can pause this video and try to write it down, or you can do a screenshot so that you can write it down. If you have any question, please do well. Feel free to drop the question in the comments and I'll be there to respond. I want to believe you got value from today's class. If you've gotten value, you can also go to the comment section and type in value. Tell us which of the three theorems actually was quite cheaper for you or that you're getting to learn. If you're just getting to learn the three, you can write 1, 2, 3. If it's number one, you're just getting to learn, do well to put it in the comment section. Share this video with your friends. If you have not subscribed to this channel, I don't know what you're waiting for. That means you don't like me. But please, if you do, if you're getting value from these videos, please subscribe to our channel and share with your friends. Thank you for being a part of Learn Something in 3 minutes. We'll see you in the next edition. Bye for now.